everyone, and welcome to the last lesson of topic 7. Today we are going to talk about the side splitter theorem as well as the mid-segments of triangles. So with the side splitter theorem, we talked a little bit about this before, but you are taking two parallel sides and it's dividing up our triangles proportionally. So that in this example here, AM is to MB is the same proportions as AN is to NC. So you will see this when you have these parallel marked segments on our diagram. So in example 1, following kind of along with the diagram, we can take 18 to our missing side length. That is going to correspond the same way that 15 to 10 will. So top to bottom, I like to say on that. Cross multiply and solve, we have 15 times x, 18 times 10, so that's 180. And then 180 divided by the 15, x is 12 on that one. In our second example, notice that we are still looking for one of these segments here, but they didn't officially give us that small piece. Instead, they gave us the entire side. Well, we know by the segment addition postulate that 13 minus 7, big guy minus small guy, is going to give us our remaining piece here of 6. Now we have top to bottom, so x over 12 equals top to bottom, 7 over 6. Cross multiply and solve, 6 times x is going to equal 12 times 7, which is 84. Divide both sides by 6. This time x is 14. All right, on this last example, notice that we are looking for officially this full segment length as our final answer. So a couple ways we could set this up, but one way we could do this is by looking at that missing piece there, and then we could eventually add them together to find the full segment. So again, we can kind of set this up. 49 over x, top of the triangle to the bottom, is going to equal 28 over 16. Cross multiply and solve, we end up with 28 times x equals 49 times 16, which is 784. Divide by the 28, x is also 28. Now again, x, we said, is this piece right here, right? And we want, however, as our final answer, the question mark is that full side of the triangle. So what we could do is we can add the two segments, 49 plus 28, for a total of 77 units on that one. Okay. The next example is for you to try. You are finding that missing segment. The next one, you are also going to end up finding our missing segment over here. Now down here in the next bit of examples, we are also looking not only to find that side length, but particularly to this time find the value of x in our expression. So start off again, setting up your proportion, top of the triangle to the bottom of the triangle. All right, so notice again, I call the top just up by that vertex, so 2 over 7. Well, if I say 2 over 7, I then have to say 4 over 2x plus 6. So lining up those corresponding pieces on that. Cross multiply and solve. Reminder to be careful when you're multiplying 2 times the whole expression, 2x plus 6, we need to make use of those parentheses. And then distribute. We have 4x plus 12 equals 7 times 4, which is 28. Subtract over the 12. 28 minus 12 is 16. Divide by 4, x is also 4. All right, now on our next example, notice this setup here, okay? We are given this full side here. So another way we can kind of use this side splitter to help us find x with that, think about I could also do top of my triangle to the whole side. So 15 plus 35 is 50. And I could say this piece here of this triangle is 15. That corresponds to that whole side, which is 50. The same way on this one, this top piece of the triangle, 24, corresponds to its whole side, which is 21x minus 4. Cross multiply and solve. We have 15 times 21x minus 4. That equals 24 times 50. Distribute that 15 to both pieces. We have 315x minus 60. And then 50 times 24 is 1200. Add the 60 to both sides and divide by 315. X equals 4 on that one. All right, last example on this page, you are solving for x this time, given those lengths. Now on the back, our second theorem for today is the triangle midsegment theorem. And this is created when a triangle divides two midpoints. So notice G is a midpoint of side DE, H is a midpoint of side EF. So we know that that's a midsegment because it's connecting those two midpoints. And what that tells us is that that midsegment length is 1/2 the length of the side it is parallel to, aka that third side of the triangle. So G to H is half of D to F. Now, looking at example 6, we see that they are giving us that mid-segment length. And again, we know it's a mid-segment because it's connecting those two midpoints, E and then F. So then this third side, G to I, of our triangle would have to be double the mid-segment, so 24. On the flip side, in the next picture, again, we are given this mid-segment here connecting the midpoints. It needs to be half the length of that third side, so only 11 units. So as they ask us for different measurements inside of our figure, okay, reminder, as tempting as it is to say that these two are congruent, that is not correct. We know that if this is a mid-segment, XY, D to E is split in half by point X, D to F is split in half by point Y. So D to X would be 6, and then because D to Y is 4, so is Y to F. Okay, again, picture's a little misleading. The mid-segment itself, X to Y, is half of this third side. So 8.5 would be the length of our mid-segment. So as we are being asked for answers here, X to Y, again, is that mid-segment. It is 8.5. D to X, we said, is 6. And then Y to F over here would be 4. All right, you are trying the next one, okay? What are the lengths of the following segments? X to Y, so be careful this whole side. X to Z, and then finally T to Z. All right, our last example is asking us to solve for the value of x. Well, again, with our mid-segments, we know if we double our mid-segment, it then will equal that third side. So again, if I double my mid-segment expression here of 3x minus 31, that has to equal the third side of my triangle that it's parallel to. Distribute and start solving. We subtract x from both sides and then add the 62. Be careful because we add the 62, negative 2 but plus 62 is actually 60. And 60 divided by 5 gives us our final answer of x equals 12. All right, there's one last example for you to try. Again, keeping in mind the mid-segment doubled equals that third side. Thanks everyone for watching.